Hello everyone, Mr. Harper here again. I want to continue our discussion of the digestive system. Let's review a little bit before we start. So we talked about how the digestive system has four phases: ingestion, digestion, absorption, and elimination. Ingesting, getting food into your mouth, and at that point that's where digestion begins, which is breaking down food particles. Two ways in the mouth. There's mechanical digestion, the actual physical chomping and moving and tearing and rending of the food by your teeth, and chemical digestion from the saliva. There's a enzyme in your saliva called amylase that starts to break down of carbohydrates. At that point, the food is all nice and moistened by saliva into a ball. It's called a bolus, and it is swallowed down your esophagus, the tube that attaches your mouth to your stomach. And a muscular action called peristalsis pushes that food down to the esophagus, where it enters the stomach, where more digestion occurs. Both chemical digestion from an enzyme pepsin that breaks down proteins, and from hydrochloric acid that breaks down just about every kind of food molecule that you eat. Food is also mechanically digested in the stomach by churning actions. The food is being pushed on by the muscular walls of the stomach. At that point, we have this food broken down into a mixture that resembles roughly oatmeal, and it is called chyme, partially digested food. And that's where we want to take up our story today, because today I want to talk to you about the last part of your digestive tract, or your alimentary canal, which is another name for your digestive tract. And that last part where the digestion part occurs, and that's in the small intestine. Small intestine, as you can see from this picture that I have in front of you, is the largest part of your alimentary canal, your digestive tract. The first part of the small intestine is called the duodenum, and that's where we want to start our discussion today. So this small intestine is a muscular tube. It goes from the pyloric sphincter that is at the point of attachment with the stomach to the ileocecal valve or sphincter, that's the attachment of the small intestine to the large intestine. The small intestine can be up to 22 feet long, and it's coiled back and forth and back and forth and back and forth in your abdominal cavity. Main function is chemical digestion. There is no mechanical digestion occurring in the small intestine. In the small intestine, there are lots of enzymes that are secreted that complete the digestion of carbohydrates that was started in the mouth. There is more of the exact same enzyme that started the chemical digestion of carbohydrates, the amylase, started in the mouth. It's finished in the intestines, in the small intestines, with that exact same enzyme. There are also enzymes that complete the protein digestion that chemically start at the stomach. Fat digestion begins and ends. It's completed in the small intestine. And at this point, everything that is digestible, all the nutrients are absorbed from the small intestine through the walls of the small intestine into the bloodstream, where it's carried all throughout your body to be used by your cells. All the waste products that your body cannot digest remain in the small intestine and then travel into the large intestine. Well, let's see if we can, sorry about this, if I can get the slide to advance. There we go. So, in the small intestine, there are some accessory organs that are not part of the digestive tract, not part of the alimentary canal, but they secrete things into the small intestine that help with digestion. And those things are primarily the liver, the gallbladder, and the pancreas. The liver makes an enzyme called bile. It is stored after it's made in the liver in the gallbladder, little green sac that hangs from the lower part of the liver. And then there is a duct, a bile duct it's called, that releases that bile into the small intestine. And the job of bile is to take, it breaks apart, or emulsifies, it's called, breaks into small pieces, large globules of fat. It doesn't digest the fat, it just breaks the fat into smaller pieces so that the enzymes can then get at those smaller pieces more easily and begin to break them down and to digest them into their components. Additionally, the pancreas secretes a number of enzymes that help to break down carbohydrates and fats, and it also secretes sodium bicarbonate. Now, let's stop and think about this for a second. Sodium bicarbonate is a base. And remember back to discussions you had in other science classes An acid and a base are on opposite ends of the pH scale. Anything below 7 is acid, anything above 7 is a base. And when chyme, that partially digested food, comes out of the stomach, now remember, in the stomach, hydrochloric acid was put into the stomach to help break down food, but the walls of the stomach did not get digested or eaten into by that acid, because the stomach has a lining of mucus that protects it. And remember that acid reflux, if the acid goes back up into the esophagus, it eats into the walls of the esophagus and you get that heartburn or acid reflux disorder. Well, if that chyme goes into the small intestine and it's really acidic, it's going to do the same thing to the walls of the small intestine. It's going to eat into them because the walls of the small intestine also don't have mucus. So the way that your body prevents this is that the pancreas secretes sodium bicarbonate that neutralizes that acidic chyme from the hydrochloric acid the stomach made. Because when you put together an acid and a base, they neutralize or cancel each other out, and they come closer to the 7, the middle of that pH scale. So the pancreas has multiple jobs to do here in the digestive system. It neutralizes the chyme, and it also secretes enzymes that continue breaking down your food. In addition to that, it also secretes insulin that regulates your blood sugar. So the pancreas has lots of jobs to do. Now, let's talk a little bit about this absorption, this third phase of the digestive system. Remember, ingestion, putting food in your mouth; digestion, breaking it down. So now we've completed the digestion of those nutrients. They're all broken down into basic nutrients that can then be used by your body. They have to be absorbed out of the walls, right through the walls, I should say, of the small intestine into the bloodstream. And the small intestine has some neat tricks to help this happen. It has 3 features that increases the surface area of the walls of the small intestine so that a maximum number of nutrients can get absorbed. First off, you can see from this picture of the interior walls of the small intestine, the wall of the small intestine is folded over and over and over again. And by folding it, you can get more surface area. Think of a piece of paper. If that piece of paper is flat, it takes up a good bit of space, but if you can also wad it or fold it into a little ball, now it's taking up a smaller amount of space, but it still has the same amount of surface area. So these circular folds are the first way that the small intestine increases surface area. The second way is on these folds there are additional little finger-like folds called villi. Oops, sorry about that. Finger-like projections off the walls of the small intestine, off the folds. And on top of that, there are small microscopic extensions that we can't even see. Here's a villi, and on top of the villi are little small fingers that we can't even see because they're microscopic, and we call those microvilli. Between the folds, the villi, and the microvilli, we increase the surface area of the small intestine greatly so that food can readily be absorbed. All those digested nutrients can be absorbed into the bloodstream. And you notice something. You see the blue and the red. Those are veins and arteries. Those veins and arteries run right through the middle of those villi so that the blood supply is very close to the area where it needs to be absorbed. So after the, oops, went to slide too many. So all the broken down food has been absorbed. The only thing left now in the small intestine are waste products, things that your body can't digest. They'll continue their journey through the alimentary canal to the next major organ, that's the large intestine. All those nutrients that can be absorbed are transported through your bloodstream to all the cells of your body. So today we've talked just briefly about the small intestine. Small intestine is the largest part of your alimentary canal. Small intestine is where chemical digestion occurs. Once chemical digestion is complete, then after that absorption occurs. Anything not absorbed continues on to the large intestine. Digestion is completed by the time you're in the small intestine. We'll talk more tomorrow.